Hi everyone, thank you so much for tuning in for our special developer meetup at Connect Digital. You might ask, what makes it special? Well, Connect always brings together MuleSoft experts from all corners of the world, and so does our developer meetup. Each time at Connect, we receive amazing speakers from our developer community. My name is Sabrina Maréchal, and I lead developer community programs at MuleSoft. Over the past 4 years, I've seen the growth and the vibrancy of our developer community increasing a lot, and it's been amazing. So, what's a developer meetup? Well, MuleSoft meetups are developer-centric events led by our community for our community for you to share knowledge around Anypoint Platform. We have a pretty data-centric agenda today, and I'm very happy to welcome two well-known speakers. Before digging into today's agenda, let me remind you that today's presentations might include some forward-looking statements and that you should base your purchasing decisions based on products that are currently available. All right, so let's look at today's agenda. Some of you might be new to the MuleSoft community, so I will give you an overview of what it means to be a part of it and how you can engage with other developers in our MuleSoft ecosystem. Then we'll welcome Vera from UCSF, who will share with you how they use dynamic data weave to provide a connected experience to their patients. Lastly, we'll have our MuleSoft ambassador Joshua Herney, who will share with you the latest updates on data weave, the update function. We'll conclude the event with some time for Q&A with our speakers using the chat window. Feel free to ask questions also during the presentations, and we'll be happy to answer. All right, so let's dig in. For the ones among you who are attending a MuleSoft meetup for the first time, welcome. And for our regulars, welcome back. So what's the MuleSoft community? Our community is a vibrant ecosystem of more than 50,000 MuleSoft practitioners from all corners of the world with various experiences. Thanks to this diversity, the community is a great place for you to share and evangelize your work by demonstrating your skills, helping others, and build your reputation. It's also a great place to see all of the amazing work other developers are doing with the platform and get inspired by what they do. And it's also the perfect place for you to meet with your peers and build meaningful relationships in our ecosystem. There are many doors to our community, and one of them is online. You can join us via our Help Center. Our Help Center gathers all of the resources developers need to be successful with Anypoint Platform. It links to our community forum, our training forum, our support portal, and many other resources, including our documentation and tutorials. Thanks to our forum and its 40,000 members, the Help Center is a great place for you to ask questions and also help others. By helping others, you get to build your reputation in our ecosystem and become a mentor for others. Our Help Center also offers interest-based discussion groups, so you can discuss broader topics and mingle with developers who have similar interests. We have groups based on locations, on training courses, and more. Our community is also active on the MuleSoft blog with technical stories and how-tos published every month. We also feature the best content from our developer community regularly. Please reach out if you would like to contribute content for our blog because we're always all ears. We also have developer groups on major social media platforms such as Facebook, LinkedIn, and Twitter, where you can connect with your peers and get answers to your questions. Another way to engage with the MuleSoft community is by meeting with other developers either virtually or locally. Meetups are community-led events for developers to learn, share, and network together. My team is here to support the amazing volunteers who run these events, but ultimately the content is up to you. You tell your community leaders what you want to learn about. Because the content is up to you, we've seen a large variety of content being delivered at meetups. It can be customer use cases, demos, sneak peeks, hands-on workshops, how-tos, you name it. It's easy and rewarding to get involved in MuleSoft meetups, regardless of where you are in the world and regardless if the events are virtual or in person. You can join a group to make sure that you are notified when they organize a new event. You can speak and deliver a presentation on something you've built with Anypoint Platform to other users in your area. And if there is no group in your city, or if you would like to get involved in the logistics of the one you are attending, you can apply to become a MuleSoft Meetup leader. Our team reviews applications and add new leaders to our program every week. You can join a group, apply to speak, and apply to lead a meetup group at meetups.mulesoft.com. One particular thing I would like to call out about meetups is our virtual meetup group. These groups are global and based on language. In the current context, they are blooming and host 1 to 2 events every week. These events are hosted either on Zoom or live stream on YouTube. Our English group has regular events, while our new Spanish group started recently and is about to have its first event. Make sure to join these groups at meetups.mulesoft.com to be notified when they announce new events. Meetups are also in-person events, and this is what our global presence looks like. More than 250 amazing volunteers from customers, partners, and even MuleSoft make meetups happen across 135 cities in 36 countries in the world. In North and South America only, we count 64 groups in 7 countries. And in any given month, we see anywhere between 20 to 30 meetups happen. More than 30,000 developers have joined a MuleSoft meetup group already. And so right now, on top of the virtual groups I mentioned just before, many local groups are also hosting virtual events to keep their members connected with each other. Now is definitely a good time for you to join your local group so you can be notified when we organize new events and you can start meeting with other users in your city. In our community programs, we often stumble upon incredible contributors who go above and beyond to help other developers. Meet the MuleSoft ambassadors. Several of them are attending Connect right now and are present in our online chat, so make sure to say hi. Our ambassadors have been contributing to the community for a long time in multiple ways. They create amazing content, they speak at events, they organize meetups, and they always give a hand to other developers. One of them, Joshua Ernie, is going to speak a little bit later. I'm sure you're thinking it must be really cool to be a MuleSoft ambassador, and you wonder how you could become one as well. Well, the first step for you to take is to become active in our community, just like they did. You can create content, share your experience on MuleSoft, help other developers, organize and speak at meetups, just like they did. A new application process is going to open in the next few months, so make sure to join our community to stay in the know. So to recap, the developer community is the best place for you to sharpen your MuleSoft skills, build your reputation in our ecosystem, and make new friends. Join us today, online, in person, globally, and locally. We're waiting for you. You can find more information and links to our different programs at mulesoft.com/community. Thank you. If you have any questions for me, please ask in the live chat and I will be happy to reply. Next up, we have Vera from the UCSF, who is going to share with you how they are using dynamic data weave to provide secure access to the UCSF EHR data. Vera, take it away.
Thank you, Sabrina, for giving us an opportunity to present at Meetup. Good afternoon, good morning, good evening, depending on which part of the world you are from. My name is Veera Raghavan Gopalakrishnan. I'm a MuleSoft developer at the University of California, San Francisco. My colleague, Mr. Sony Ranjitkar, is supposed to join me today, but unfortunately, he cannot make it. And thank you, Sony, for helping me to put together this presentation. Today, we are going to discuss how we use the data view scripts at UCSF to add more security to the EHR data access through APIs. So the agenda for today's presentation is first we go over the goals and the frameworks for the EHR industry. And the standards and framework widely used in the EHR industry, and the proxies we developed at UCSF, and some of the projects that are using these proxies, and what challenges we faced when we implemented this proxy and data access security rules at UCSF, and how we externalize the data view scripts and we stored it in the Salesforce custom metadata table, and what are the benefits, and we have a quick demo at the end. If you have any questions during this presentation, you can always ask in the live chat on the right side. We are going to discuss our goals and the regulations that motivated the health healthcare organizations to adopt EHR technology. Health Information Technology for Economic and Clinical Act passed in 2009, and this act was passed as part of the American Recovery and Reinvestment Act. They included incentives for organizations who demonstrate the meaningful use of certified EHR technology, and this was led by CMS, Center for Medicaid and Medicare Services. A meaningful use primary objective was to improve the quality, safety, efficiency of the healthcare data, and also promote the interoperability of the data across organizations and involve the patient and their families in their health. A meaningful use was implemented in three different stages. Stage one was focusing on like adopting the promoting the adoption of EHR technology and data gathering that laid the foundation for the electronic capture of clinical data. Stage two was focusing on more on emphasizing on the clinic care process improvement and also exchange of patient information in a well structured format. And stage three was focusing on improving the healthcare outcomes. And the objectives are making the healthcare data easily accessible for patient and also the data easily interoperable across the different hospitals. So when the patient go from one hospital to another hospital, they don't have to repeat the same test again and again. So this help us the patients to cut down the cost and also time, and also it increases the utilization of the healthcare data that we capture using the EHR system. So the standards and framework. Um, there are standards widely used that are developed by HL uh, 7 organization, and the leaders from different healthcare industries, they all join together and come up with HL7 standards. The HL7 version 2 was widely used across many hospitals, but the problem with HL7 version 2 is that it's all pipe delimited and very difficult for the any new developers to understand the structure unless you work on the healthcare industry for many years, and it's easier for you to understand what the data means. It's very difficult for new developers to understand. And the HSL version 3 was XML based, and when the SOAP web services was getting popular, they came up with this XML version of HL1 version 2. But then the hospitals were not widely adopted to HL1 version 3 because it didn't add much value. And then like the REST API get popular, and all the new developers started using REST API. So then HL1 organization came up with a FHIR data model, fast healthcare interoperability resources. This is based on the REST resource model. They divided the data model into like different resources like patient resource, provider resource, allergy resources, lab results resources. So it's very easy to develop a REST API and using this FHIR model. And then the framework, like it's always challenging to integrate any third party application within any EHR system. So they come up with a stand framework called Smart on Fire. It's a substitutable medical application and reusable technology. The Smart on Fire really helped to integrate the third party application within the EHR system. So the providers, the doctors can choose their own, like the app they like, which will help them when they make a clinical decision. So that can be easily integrated with the EHR system, and then they can use it at the point of care to make the well-informed clinical decisions. So then the EHR vendors started developing these APIs, and when we start looking at those APIs, we come across some limitations. Because like at UCSF, we use the EHR system to store patients from other affiliated hospitals, and we don't want to expose those patient data through the EHR APIs. We want to expose only the UCSF patient data. So that kind of we want to add additional security on top of what the EHR vendor provider. So we have to come up with a process and logic to filter those non-UCSF patient through the APIs. And also the vendor APIs, they developed a lot of older APIs over a long period of time, and it was developed for by different developers. So they haven't really don't follow any standards when we want to use their older APIs. So we have to account for those older APIs as well and add more security to those old APIs. And also the vendors, they came up with their own registration portal for the app that want to use those APIs. They have to first register in their app registration portal, which kind of added challenges to us because we want to use the Mule API manager, but somehow you need to come up with a process to sync the client IDs from the EHR app registration portal to the Mule API manager. And also the URL for the resources, it's all fixed. We don't have flexibility to change it. Only part we can change is the base URL. So that kind of added a more challenge for us. So the proxies we developed at UCSF, we developed three different proxies for exposing the HR APIs. One for Fire, the other one is for the non-Fire APIs, and the third one is the custom APIs that we built at UCSF to expose the HR data. So whatever is not available in the vendor provider APIs, we developed our own custom APIs. So these APIs are developed on the Mule platform, and we added up all the needed security for our organization in the proxy flows. So here are some projects that are using the proxies. We can go over the three different flavor of applications that are using these proxies. The first one is a newborn weight application. It's a smart on fire app. It's used by the providers from the pediatrics department. When they launch this application from EHR system, the call goes to the newborn weight app, and then it goes and gets the patient related data like birth weight and the delivery method, all those data related to the baby. It's pulled through the APIs. Then it renders a growth chart to the provider on the EHR system so they can see the growth chart of the baby and then make the decision and see how the baby's growth and whether they need to take any treatment. It's all like informed decision that provider can make at the point of care. So this is a smart on fire app launched from the EHR system. And the next one is the Luma app. This is a patient self-scheduling app, like the patient upcoming appointments are sent to the Luma app. Then the Luma app will send a reminder to the patient, either through email or a text message, depending on the patient's preference. So once the patients get the reminder, they can either confirm their appointment or they can cancel it or they can reschedule it. So based on their decision, then the Luma gets the patient's decision about that upcoming appointment. Then it will call the backend APIs through the Mule proxy, and then it will confirm or cancel or reschedule the appointment. This is a patient-facing app. Then the third app is used by the researchers, the Eureka app. Whenever the patient signed up for the research studies, the Eureka app get the data from the EHR through the APIs about their history, their lab results, so that the researchers, the principal investigators, can look at the patient data and understand how their progress through the research studies. So these are the three different applications that are using our current Mule API proxies. But there are many, but I thought these three are three different flavors of the application. So, what are the challenges we faced when we first implemented this proxy on the Mule API Manager? When we first developed this proxy, we incorporated all the validation rules, redaction rules within the Mule flow. And also, when we want to add more application who wants to use this application, they come up with a different requirements for the data validation and data redaction. So when we looked at the EHR APIs, they provided very limited scope for doing any data filtering or data validation. So we have to incorporate those logic within the proxy flow. So since we are included in everything within the flow, it became more challenging for us to add any new requirement to make any changes to the flow itself, as when new application wants to use these APIs. So that kind of made us very limit. Took long time for us to make changes, and also the application who wants to use these APIs were not happy because it's taking more time for us to make any changes. So there are many demand for using these APIs, but there are pain points. They felt like it's taking more time for them to start using these APIs. So that made us to think through this process and come up with an idea that should be faster and easier to maintain. So then we thought about like why can't we extract all those logic data validation rules and data extraction rules into a separate table or file that can help us to easily like make changes. So that's how we ended up in extracting all these dynamic database scripts into a file and store it in an external table. Let's go through this proxy flow. When we get an incoming request for an API, first, we check an authorization check. We check if it's an WAUth or basic auth. If it's an WAUth, we get the access token. We don't get the client ID. So we have to call an introspect endpoint to get the client ID from the EHR system so that we can collect all the Mule API analytics in the Mule API manager. So then we check if it's a basic auth, then we'll move forward and we'll check whether that particular client has got access to that API or not. Then once we validate that, we'll check for any input validation, like whatever the data that the API caller is requesting, whether they have access to that data or not. So then we use the input data validation using the external database scripts or MEL expression. Then then we go through the business rule validations where we check whether that whatever the data that they're requesting belongs to the UCSF patient or not. If it doesn't belong, then we'll say like we'll send back 403. You cannot call the data. Then if they allowed um, to get the data for use as a patient, then we have to do additional checking whether that patient is a confidential patient or not. Like if there's a confidential patient, then we have to check whether the user has access to look at the confidential patient data or not. So those are all additional business rules validation that will do in the proxies. After that, we send the call to the EHR API. Once we get the call back, then we do the data redaction. Like we'll filter out any sensitive data in the API response. Then we send the response back to the caller. So let's go over how the externalizing database scripts. Like we extracted this database scripts and we stored that in a custom metadata table in Salesforce, and that includes the data validation and also help us to have a different kind of requirements for each API client. And also we can redact the sensitive data for a specific client. Like it's very easy for us to maintain and make changes on the fly. And also we read those configurations and we load it in the memory whenever a process starts, so we don't have to go and hit the Salesforce every time we get the call, and it improve the performance. And also like we can do the changes in a real time and enable or disable the scripts in real time, and we have the way to refresh the cache whenever we make changes. Here is a sample validation script. The first one is a data view script, sample script. I'm showing a very simple script here, but data view is very powerful. You can do more complex than what I'm showing here. So the first one is we are allowing only the particular client who applied this data validation rules cannot use the extra items or extra extensions. That should be empty when they call this particular API. Similarly, the null expressions, so here we are checking whether that the context name is only encounter or patient allowed for this specific client when we apply this validation script. So it's very easy to make kind to come up with this validation script and load that into custom metadata table in Salesforce. Next is the data view script that we used for redacting a response, API response. This is a referral, like someone if wants to get a patient referral, we'll check whether the referral belongs to any of the departments. The application is looking for referrals only in a specific department. So we have to filter out based on the caller. We have to filter out if the referral belongs to any of these departments. So we have the database script to redact those data. So here is an example of Salesforce custom metadata. We are going to go into the details of how we storing the external database scripts in Salesforce custom metadata. The first one here we are showing. I'm showing the allowed path for the specific client. We have the client ID also stored in this table and the path information, and also whether the specific path is required a validation. It's a required validation field which is checked. So this particular path API needs a input data validation, and also it requires a response mapping. We have to redact the data when in the API response. So this is a script we store in the custom metadata, and this gets read in the initially when the flow start, and it loads into memory. So this is an example of validation expression. Then we store a validation expression where we can check for the extra items and whether it's a null or if there's some cases we allowed only a specific items to be requested through the caller. And we can have multiple validation rules for the client. So we can have which go through each one and apply those data validation rules when we check when call comes through the mule flow. So what are the benefits of storing in an external table? As I mentioned, like we had a so requirement varying from one client to another client to do the different kind of data validations and data redactions. So it was not easy for us to implement those kind of validations in the raml. So by doing this way, by storing it in an external table, it's very easy for us to make changes to the data validation and redaction rules. So that gives a flexibility for us and also speed up our time to onboard any new applications who wants to use these mule proxy flows. And also it reduced cost and increase the efficiency of our team, so we can focus on more different kind of work instead of focusing on changing these proxy flows, and also easier for us to maintain. And at the end, like it made the applications who wants to use this APIs much happier, and they can start using these APIs sooner and play around with it and explore these APIs much faster. So we are going to show a quick demo of how we store the database scripts in the custom metadata table, and we'll also show you calling those APIs through Postman call. Here I'm showing the custom metadata table for showing the allowed path information. As you can see here, we have the allowed path for these health stack applications, and it required validations, and it also required a response mapping. And we are redacting the national identifier from the response. The identifier is a social security number, and this is not needed for this application. So we kind of filtering that out in the API response. So here we are showing the Luma Health get patient appointments validation rules. Luma is allowed only to request for items 7300 and 23015. Those are the only two items that Luma Health is allowed. If they try to send a request with a different extra items, then they'll be sent a 403 forbidden, and with an error message that they can call only with the two items 7300 and 23015. So this the postman calls quickly. I'll quickly show how this being called. Um, First, we are going to look at the Loma application. I'm making a call to Loma app, and this comes back with the result. And there's no national identifier. It's also filter out for Loma applications. So next is the health stack application where we check for they're allowed to only call with the MRN. If they call with a different type, then they'll get the error message saying they're allowed to call only with the MRN. So here I'm passing with the MRN and MRN information. When the same app calls, send a request, then they get the data back with data, and there's no national identifier that's get filtered out. So say for example, if you want to filter out the date of birth also for this application, we can easily do that. When I go back to the Salesforce custom metadata, and now we are trying to filter both the national identifier and the date of birth for this health stack application. I made changes in the custom metadata, and I go here and refresh the cache. It may take a little long to refresh the cache. So it's what it's doing is going and reading the custom metadata and loading all those updated information into the cache. It built the cache. Now if I go back and make the same call again, and now the date of birth was removed from the response. So next we'll look at one of the example. As here I'm making a call using the Luma client. We saw like only 7,300 and 23,015 extra items are allowed for this Luma. But if we try to send a different item, it will say it's only these two items are allowed in extra items. Say for example, if I change this to 7,300, then it creates the patient appointments. So you can, as you can see, it's very easy to make any changes to the data, the web scripts in the custom metadata, and we don't have to redeploy the Mule flow. Whenever new application wants to use this API, we just make changes in the custom metadata table and refresh the cache. They are set to go. So this kind of helped us to speed up our onboarding process and help the new application who are interested to use these APIs much faster and increase the usage of this Mule API, proxy APIs throughout our organization as more and more researchers and more application wants to use these APIs at UCSF. I hope you enjoyed this presentation, and thank you. If you have any questions, always post it on the live chat. We are here to answer if you have any questions. Thank you.
Thank you, Vera. It was a great presentation. If you have any questions for him, please ask in the live chat, and he will be here to reply until 2:30 p.m. Next up, we have Joshua Ernie, MuleSoft ambassador and senior software engineer at MS3. I'm sure you've heard of Joshua's name before. He's a globally recognized data weave expert and regularly publishes articles on his blog and speaks at meetups and other events. Today he's going to share with you what he thinks is the best thing that has happened to data weave since sliced bread, the update function. Joshua, take it away.
Hi, my name is Joshua Ernie, and welcome to my Connect 2020 virtual presentation. The update function, the best thing to happen to data weave since sliced bread. Let's get started. So let's quickly go over the agenda for the presentation. Overall, I'm going to try to keep things short and simple, just giving you the context that you need to understand what the update function is, why the language needed it, and how you can effectively use it. First, I'm going to talk a little bit about me and my background. Then we'll dive into why it's been so difficult to modify single values in nested data structures in DataWeave. And I'll briefly discuss some of my attempts at fixing this problem, why they didn't work, and then we'll follow up with the solution that the DataWeave team came up with, which is the update function. I'll cover how you can use this function to elegantly solve the stated problem, as well as covers an issue that you might encounter while working with this function with XML. And then we'll wrap things up with a conclusion. So who am I? I've been a MuleSoft ambassador for about 2 years now. I'm also a developer and architect focusing in the application integration space. I've been working with MuleSoft products for about 4 years, and I'm the author at journey.io, which is a DataWeave-centric blog that I write and talk about a lot of things related to DataWeave transformations. Let's talk about the problem real quick. For example, if you've ever tried to mask data in a payload like personal information, emails, etc., you've probably run into this problem before. And if you haven't, you're in luck, because it's already been solved. So an example of this problem that we're going to use throughout the presentation is on the slide here. How do you transform this where we have a payload that contains multiple levels of data and transform just a single element in it? So how do I change hello muleys into hello world? Let's look at some of my attempted solutions. So my first attempt stemmed at what I already knew about Python. In Python, you can use selectors on the left-hand side of an equal sign to define where you want the value on the right-hand side of the equal sign to be placed. And maybe you've tried something else like this before. Guess how it went? Unfortunately, it didn't work out too well. The syntax is completely invalid. DataWeave won't even run this particular code because selectors like payload.root return the value that they select. So if you were to go and evaluate the code that I was trying to use, it would be like trying to set a string equal to a string. And that doesn't really work. So I took some time and I reflected a bit on what the actual problem was. So in DataWeave, all of our values are immutable. We can't change data in place. That was my main problem. So because of that, what I needed to do was not only update the value that I was interested in updating, but also rebuild the entire data structure from the input structure so that it all made it into the output. And finally, I realized that the data that I'm working with could probably be represented easily as a tree, so that my best strategy moving forward was likely going to be recursion. And if you look at the image on the bottom of the slide, you'll see how the data structure that I provided earlier can be represented as a tree. We have different nodes like root, level 1, data, and then we have the values as leaves on the end of this tree. So the big problem when trying to use DataWeave to update values in a nested data structure is that it's a simple use case that requires the user to implement an error-prone and rarely needed technique in data transformation, which is recursion. Now, when I say it's rarely needed, I just mean that there's many situations where recursion can be concealed by a good implementation and a nice API. And as we'll see, this is certainly one of those situations. So as a second attempt, I wrote a couple of utility functions to hide the recursion and provide a better API for dealing with these kinds of situations. The function apply to values takes in a collection and a function that describes how to modify all the values in the collection that was provided. This is later superseded by the mapLeafs function. The second function I tried to create, apply when key, is the same as apply to value, but there's an additional conditional logic step applied, where you can supply the value of the key that can also be used to determine if the value should be modified. Unfortunately, this was a failure as well. Apply to values indiscriminately applies the function to every value, regardless of where it exists on the data structure. And apply when key has no knowledge of the path that it took to get to the value. So it will update both instances of data. If you look at the pane on the left-hand side, on lines 4 and line 6, you'll see we have hello muleys and hello connect. And when I use the apply when key function to just select data to do the update on, which you can see on line 18 in the center pane, it just indiscriminately, anytime you see the key data, it applies hello world to it. And we only want the output on line 4 to say hello world. But the biggest problem with both of these solutions is that neither solution can update attributes, which means they're incompatible with XML. So DataWeave's update function comes to the rescue here. In Mule's 4.2.2 release, it introduced the values module, which includes the update function. The update function increases the ergonomics of updating nested data in place. And I say in place in quotes because data weave isn't actually modifying the values in place. As you know, all of the values in data weave are immutable. What it's doing instead is rebuilding all the data around that new value, but insulating the user from all of that complexity. And what's also nice about the update function is that it can update XML attributes, and it keeps track of the path as it crawls through the data structure. So root.level.data and root.level.level2.data are recognized as different keys. Here's an example of the update function in action. On the left pane, you can see the input that we've been using, and in the center pane on line 4, you can see that we need to import this function from the values module, and on line 6, you can see it in use. If you look at the output pane on the right-hand side, you can see that the update function successfully updated root.level1.data and left root.level1.level2.data alone. So let's review how you can use this function. It's really easy. You describe the data that you want to update first, you name the update function, and then you provide an array that describes the path to the element that you'd like to update. Finally, you follow this array with the with function followed by the value that you want to provide for the update. So does it work with XML? Of course. If you look at the left-hand side, that's just an XML representation of the JSON data that we were dealing with earlier. In the center, the code is completely the same, and on the right-hand side, we can see an XML representation of the output, where on line 4, we've updated that value to hello world. And if you're wondering about XML attributes like I was referring to earlier as a key problem in some of my solution attempts, we'll cover that in a couple slides. So there's 3 kinds of elements that you can target when you're specifying the path in the update function. The first one is a field, which is, in other words, an object key. And we'll use a string in any time we want to define that particular So there are 3 kinds of, There are 3 kinds of, all right. There are 3 kinds of values that you can use to target data. So there are 3 kinds of values. Keep going. All right. So there are 3 kinds of values that you can target data on. I just think I wrote this. I need to stop reading this sentence. Okay. There are 3 different ways you can target data using the update function. One is fields, which are object keys. To do that, you use a string in the path. You can also do indexes, and for that you use a number, specifically an integer, in the path, and you can use that to update arrays. And finally, you can use attributes, which you'll use the adder function included in the values module. And let's see an example of that in the next slide. So on the left, you can see we've defined an attribute context on the root element and set it to MuleSoft. In the center pane where the data weave script is, we first import the update and adder functions. And when defining the path to an attribute, what we want to do is first define the element that the attribute is placed on, in this case is root, and then we want to wrap the attribute's name in the adder function. And then as you can see, we replace this with Salesforce, and on the output on line 2, you can see the context was modified from MuleSoft to Salesforce. Let's go over a common gotcha when dealing with the update function. Objects in data weave support duplicate keys. And when we look at XML, it's clear why. If you look at the right-hand pane here, this is a very common XML pattern where we have an encompassing element followed by a repeated number of child elements. Now, this isn't only supported in XML, it's supported in JSON as well. The JSON spec doesn't explicitly state that duplicate keys in an object are invalid. It says that they shouldn't be used, but in the definition of should in that particular context, it means they're technically allowed, but should probably be avoided. DataWeave still supports duplicate keys in this case because it needs to support them for XML. So just note here that even though this might look odd, in many programming languages, having repeated keys is not okay. In DataWeave, it's allowed. So the question becomes, how do we update objects with duplicate keys using the update function? If we try updating these duplicate keys by selecting the key name, DataWeave overwrites all of the instances of that particular key. So here on the left side, we have data set to hello space goodbye world in an array that contains the string hi. And when we try to update the data attribute, as you can see on line 6 in the center pane, we get an output that is MuleSoft for all of them, whereas maybe we only wanted to set the first piece of data to be hello. If we try selecting a particular key by index, kind of treating objects as arrays or maybe an ordered object, DataWeave will only match if one of the values is an array. So in this case on line 7, where we have that data set to that array with a string that says hi, that's the one that matches. If you look at line 6 here in the center pane, we have payload update and then the path to the object, which is root data 0. The DataWeave update function interprets that 0 as being an index of an array and not the index of the key of the particular object that you might want to update. So an important thing to keep in mind is whenever you're supplying numbers in the array path, they are always interpreted as array indexes and never object indexes. So getting around this issue is fairly simple, and it still avoids recursion, and we get to use all of the tools that we're already familiar with in DataWeave. I'll walk you through the simple 3-step process. First, you want to select the object that you want to update and set it to a variable. This is what I'm doing in line 6 on the center pane. Next, you want to transform the variable as needed, and I'm doing this on line 8 through line 11. And then finally, you take that variable and you use it at the end of the update function to say, this is what I want to update this existing value with. And as you can see here, we're trying to set the first instance of the key data where it says hello on line 3 on the input to say howdy. And you can see on line 3 of the output that we've successfully done that. So in conclusion, when your language only supports immutable data, updating single fields and nested data structures can be difficult, error-prone, and unnecessarily expose recursion. The solution to this problem can be wrapped in an easy-to-use interface, and the update function solves many of these problems in a way that's easy to use and easy to learn. If you'd like to learn more about DataWeave, you can check out these couple of tutorials that I've developed with the DataWeave team. And after that, if you're ready to practice your skills, you can try your hand at my practice exercises. Thank you.
Thank you so much, Joshua. If you have any questions for Joshua, Vera, or myself, please remember to ask in the live chat. We'll stay online until 2:30 p.m. to answer your questions. Thanks again for attending and see you next time.